So the next question is a bit weird. Now, looking at this triangle, it actually is starting to look a bit familiar, like all of a sudden. But anyways, they want us to prove that angle D is 72 degrees. So if you're going to work with specific figures, then here you need to make use of theorems, But the thing with this sketch now is there's just so much information, and there are just so many angles equal to X also. So from like the very first question that we worked out, angles that are equal to X, there's like 1, 2, 3, 4 angles equal to X, you see. And let me just make sure this is clear. This is D, this is E, this is F, and this is G. Now, what I can also do is let's write out other angles in terms of X, you see. So here, these are both equal to X. So this would be like 2X, you see, because exterior angle of a triangle. Now, these are angles on a straight line, right? So this is going to be like 180 minus 3X, 180 minus 3X. And then these are like, what you call it, corresponding angles, right? So that angle here is equal to 2X. So let me just try and, put arrows. So this is this. So this angle is equal to that whole thing there. So this is equal to 2X. And then, I mean, like up here, this is going to be like 180 degrees minus 3X, because these are also like, corresponding angles. So we've written everything here in terms of X, so if this is like X and X, this one here is going to be 180 minus 2X. So we've written everything in terms of X. We've done the best we can. So you're getting angle D. It looks like we kind of need to like solve for X some way, somehow, because yeah, if we don't solve for X, we are going to have a problem. So the one thing we're seeing here is, yeah, we have to obviously think creatively. And the sad thing is, I mean, from this picture that I got, I cannot see the marker location. So I don't have an idea of like, what is the total. But then let's see if, yeah, I'm not even gonna sugarcoat anything. It's even the yellow now is a bit annoying to look at. It's like, bro, the colors are just too much, just too much. But anyways, we're working on this one here. You see, asking us for the angle of D over there. You see, that's what we're trying to do. Trying to get angle. We're trying to show that angle D is equal to 72. So without overthinking it, let's see. I mean, interior angles of a triangle add up to 180. So the sad thing is, if you add all these up and you make it equal to 180 and try to do some funny stuff, yeah, you're always gonna form out. You won't get like a specific value. But then they gave us, we worked out DE over, we worked out DF over DE as like Y and 1 over there. So I don't know, are the lengths going to give us something to work with? So this is 1, this is 1, and this is 1. Let's see if this, okay, I think we have a dimension here, like for the length of the line. So maybe that could help us some way, somehow, if we maybe think of things like, the cosine rule and all that. So let's use the cosine rule to get maybe something going here. But then if you use the cosine rule in, let's see which triangle we can use the cosine rule in. I think let's use the cosine rule. But then what is the cosine rule going to help us with? If we get a length, how does that eventually help us get angle D? Yeah, that's crazy, hey, because hey, like, I think the problem here is just having this Y. The Y here is causing problems. Because if the Y was not there, we wouldn't be having these problems. Because whatever answer we're gonna get, probably gonna be in terms of Y. But let's see what comes up if we use the cosine rule and this triangle. Let's just do it. But then if we use this triangle, how is that gonna help us get X? Hey, let's use it. Let's use it and use angle D. So if you're gonna use the cosine rule, the angle here will always be this angle and this side here will always go together. So here you'll have to say FE squared is equal to like DF squared minus DE squared. Is it plus or minus? Oh, I feel like I'm forgetting the formula here. No, you have to think of Pythagoras. A squared, yeah, it's a plus here. I always think of Pythagoras and then BC, whatever. So here it's going to be like DF, DE, and then cos the angle D. Okay, let's put in what we can and see what comes out here. So this is just going to be a 1 squared. DF is like y squared. DE is like 1 squared. It's like y here. And then it's like 1 here. Cos 180 minus. So 180 minus 8, let's just do it. 180 minus 3x. Oh, no. Yup. Yeah, yeah, this is like y squared plus 1 minus 2y cos 180 minus 3x. Let's just do it bit by bit here. So you see here, this is going to be y squared plus 1. This is going to turn into a plus because we're changing this to cos 3x because of the reduction formula. So this here, 180 minus means you're going to get a negative cos. So a negative here times the negative 2y gives you a plus there. Now what are we trying to do? We're trying to get something going, So it's sad. Everything on one side here, 1 minus the 1 there. You're gonna have, let's say, 0. And then you have y squared here plus 2y cos 3x. The only issue here is we have an equation that both has x and y. So I think we could have two equations that both have x and y and then solve x and y simultaneously. Because from here, yeah, it's going to be a bit difficult to isolate something. Because if you isolate x, that's going to be a mess. Yeah, let's leave this like this for now. Another equation that we can have that has x and y, bro, what you're gonna have, man, what you're gonna have. Let's try and use the sine rule or something. The sine rule, in one of these triangles, what you're gonna do. Let's say this angle and this side, and then this angle and this side. Yeah, let's do it. So using the sine rule, we can say sine this angle, right, which is 2x over the opposite side, which is a 1. This is equal to sine x over the opposite side, which is a y. If you cross multiply here, the best you're going to have is like y sine 2x is equal to sine x. Yeah, I do feel like I'm off ramping with this question, like way too hard. But anyways, let's make y the subject with the formula. You're going to have y is equal to sine x over sine 2x. Yup, yeah. I hope I'm not off ramping too much. So this is equation 1. Let's carry on with what we have here. So this is equation 2, right? So we want to put equation 1 into equation 2. 1 into 2, where y is, you're going to put this whole thing here. So 0 is equal to sine x over sine 2x, and then plus 2 sine x. Maybe it's just because I'm not afraid to like have fractions and a bunch of stuff everywhere. Maybe that's the only reason why I'm doing all this. So carrying on here, we can't do much, hey? Sine x here, the bottom here is technically 2 sine x cos x. And then here, if you multiply everything, it's going to be like 2. It's supposed to be 3. No, it's a 2, bro. Come on. Yeah, see, man. 2 sine x cos 3x, the whole thing over sine. Let's say 2x here, cos x already. Because of our, what's that thing? Double angles. So here, sine is going to cancel the sine there. You're going to have 1 over 2 cos x. Then here, 2 is going to cancel 2. This is going to cancel that. You have here cos 3x over cos x. Likely we have cos's only. But, let's get an LCD here. The LCD is going to be 2 cos x. So here we're going to have to multiply by... Right, let's just reverse what we did here. Let's not cancel the 2 here. Let's not cancel the 2 there. Let's leave the 2's for now, because if you leave the 2's, what's going to happen is we have a an LCD that's the same, you see. So that here we can say 0 is equal to 1 plus 2 cos 3x, the whole thing over 2 cos x. And then you can multiply both sides by 2 cos x, you're going to have 0. So if you're going to multiply by 2 cos x here, multiply by 2 cos x there, you're going to have this left only. Of which this looks like we can do something here. Yeah, everything on this, take the negative to the other side. And then you can divide by 2. And then here you can get a reference angle. Reference angle is going to be equal to cos. Whenever you get a reference angle, you always use this number as it is. You don't consider the sign in front there. So our reference angle there, I feel like this question, hey, if it doesn't come out correct, is not good. Is not good. So this is our reference angle here is a 60. So that's kind of scary. So this is like a 60. So because that's a reference angle, now we can say stuff like 3x is equal to, well, we have to work with where cos is like a negative, right? So cos is a negative in this quadrant, 180 minus. So it's like 180 minus our reference angle. We don't have to do the O plus K360 thing because, like, yeah, that's not what we're doing right now. It's not, we're not getting a general solution. We just want to solve for x. So here, this is like 120. This is like 3x divided both sides by 3. What do we get, man? What do we get? What do we get? What do we get? We get like 40. But where is the 72 gonna come from now? That's the scary thing now. That's the scary thing here. Because now look, we're getting a 40 over there. 180 minus 3 times 40. You see now, this is wrong. 3 times 40 is like 120. 180 minus 120. That's like 60. Togo, I flopped, man. I flopped. Oh, the square. I forgot the square. This sucks. Sucks. Anyways, so I actually carried on and had made a mistake. Forgot to square here. But anyways, let's carry on now. So carrying on, it's gonna be sine x squared, sine squared 2x, and then plus 2 sine x sine 2x. Oh snap, I forgot to multiply the cos 3x. Cos 3x, fine. Now the big idea here is, I mean, like, if you look at it logically, your LCD here is sine squared 2x. So here you have to multiply this whole thing here by sine 2x over sine 2x. Because what's going to happen now is, I mean, like on the left, 0 is just 0. So here you're going to have sine squared x plus 2 sine x dot cos 3x dot sine 2x. And then our denominator is just this. So if you multiply both sides by your denominator, it's going to fall away. And then you're going to have just 0 is equal to sine squared x plus 2 sine x dot cos 3x dot sine 2x. So let me actually just show that actually, so that people don't get confused. So here all we did was we multiplied this side by sine squared 2x, multiplied this side by sine squared 2x. Okay, carrying on, let's see, what can we do here now? We have to be careful here, like very careful, because is beating this. The 3x, I think the cos 3x is going to be a problem there. Hopefully not, but let's see. So this is going to be sine squared x plus 2 2 sine x dot cos 3x. And then this is just going to change into the double angle, right? And then obviously what? This times this, that's going to give you like a 4 action type of thing going on there. So this times this is going to be like 4 sine squared x cos 3x. And then you can factorize. Oh my goodness, it's like coming out so nicely. Like, so amazing. So the sine squared x, you can take it out as a common factor. You'll have 1 plus 4 cos 3x over here. And then divide both sides by sine squared x. So see, divide this side by sine squared x, divide this side by sine squared x. And then what's going to happen is that this cancels this, which is going to give you 0 here is equal to 1 plus 4 cos 3x. Perfect, perfect. And then you can take everything to one side, right? No, you can just take the negative to the other side, the one to the other side. So that now you can do your reference angle stuff. So here you're going to have -1/4 equal to cos 3x. So here you need to get a reference angle. Whenever you get a reference angle, don't use this negative symbol, only use the number only. So your reference angle is going to be cos with a quarter. Let's see what the reference angle is. I hope we get something, nice to look at, because proving that that thing is going to be equal to 72 it's a problem, because our reference angle here, we're getting weird numbers already. It's like 75.52. So cos is a negative in the second quadrant, which is like 180 minus. So here 180 degrees. So 3x, right, is going to be equal to 180 degrees minus the reference angle. This doesn't look like it's going to yield something useful, but it's scary. 75.52. This is going to give us like 104.48, right? And then divided both sides by 3. What are you getting? Dividing both sides by 3, right? We're getting the 34.83. You're nah. If that's what x is, then 180 minus 3 times that. 180 minus 3 times our answer. What does that give us? 75.5 something. I don't know lie, I don't know why this one is really not working for me. For now, I'd rather not spend too much time on it. I'll look at it later. So let's pause this one. Let's stop this video. Stop.